Hey, and welcome to Keysight Eggplant Automation. Today, I'm going to be talking about the future of software quality for higher customer value. So I'm just going to take a few seconds to explain a little bit about Keysight's history. Most of you will know we've been in the test equipment landscape for over 80 years, originally founded by Hewlett and Packard. More recently, we've moved into becoming Keysight Technologies back in 2014. And in 2020, Eggplant was acquired by Keysight. So when we think of Hewlett and Packard, of course, we're going to go back to 1939. And as you can see, the garage behind here at the birthplace of Silicon Valley. So it was in this garage in 1939 where the first test and measurement device was created for Walt Disney. And you can see on the right-hand side some of the original papers written by Alan Turing on artificial intelligence, just down the road from me in Bletchley Park. Now, I was lucky enough last week to be in Munich and at one of our R&D centers, and you can see not only the garage that sits behind there, but actually 1939 and the original piece of equipment that they used, the first ever testing product, which was used for Fantasia. Now, I wanted to give this bit of brief history because obviously we've come from a heritage of testing capabilities. And in a way, we're part of testing this new digital revolution of next generation technologies. So I wanted to kind of give you a quick insight to our launch at CES this year for our radar emulator, which can emulate up to 500 different objects and can help self-drive and connected car. And of course, we're working on the 6G capabilities. And of course, we can't mention that without mentioning the digital evolution we've all been in. And as you can see, we're now in the fourth industry of cyber physical systems, networks, and also artificial intelligence. So what does that mean? Well, of course, when we talk about cyber physical systems, you could probably do an example like Sophia. And I did a talk a few years ago, and she actually replied to my tweet. But you can see on the right-hand side, some of our robots that are actually testing point-of-sale systems and actually interacting, so blurring the boundaries between the physical and the digital world. You might have also seen on some of the slides before that actually, when I did my TED Talk on cognitive learning back in 2017, I talked about digital evolution over revolution. And for most of you will probably notice the behind is the Enigma, and the Enigma spelling TED, just in Bletchley Park down the road from me, and that initial paper that I first referenced to on computer machinery and artificial intelligence back in 1950. So we've obviously come quite a long way, but I think whenever we think about artificial intelligence, I put together this quick slide around bringing the conversation up to more of an executive level. You know, there's always been a quote that everybody's responsible for quality. Now, my challenge would be by putting responsibility and accountability of everyone being responsible for quality, nobody owns quality. So being able to shift that up and start the conversation at the level of, say, for instance, the attendees today at Gartner, is how do we get that QA ops? So we've got that ability to understand quality at each part of the life cycle and kind of deal with that challenge of the ultimate pick two of quality, cost, and speed. How do we directly understand and correlate, if we invest more from a RevOps perspective, how we directly correlate that to quality and also the impact to brand? So I wanted to kind of set up that high level of how do we understand it. And of course, I'd have to reference my good friend, Dean Liffenwell and SAFE, because it gives you an idea of what that organizational governance and enterprise agility should look like within your organization. Now, we know things are much more complex. It's ecosystem to ecosystem, true E2E testing. We've got to test between a number of different solution estates, product estates, which could be a plethora of different endpoints, hundreds, if not thousands of systems in an enterprise modern organization. So how do we bring that quality lifecycle management throughout the not only SDLC, but into operations as well, which is why we're using the word QA ops, but also quality stream management in the same way as I referred to value stream management on the previous slide. So how do we do this? Of course, we know within our DNA, we've got simulation, the ability, like we did for Walt Disney back in 1938, to be able to simulate and use our instrumentation and testing devices, which are the market leader. And if test is in our DNA, but so is automation. And bringing those two, to both software and hardware together, and I use the quote, "There's no software without hardware," we're not only taking and testing the hardware abstraction layer, but also within modern software systems, what are the interconnectivity? What's the complexity that surrounds that? And that's why at an overall level, we're trying to assure the quality of that product and also prove how resilient and through validation and verification. So I wanted to kind of put in these two pillars. First, around bringing in, just like AI ops, predictive analytics to understand a bit more about test ops and a bit more insight into predictive ALM capabilities. I also want to introduce, which I'm going to break into the next slide, around our open testing architecture, the way to be able to interchange and exchange information. Now, that could be the same as open telemetry in the APM landscape. So in a way, we're trying to move what was an isolated industry into an entire new platform, connecting that intelligence from upstream and downstream ecosystems that may be within your control or could be your payment gateways or other suppliers that you rely on a daily basis. So let's talk about this new industry of ATA platforms, or automated test assurance platforms. This open architecture allows you to have the flexibility to interchange, but also test all of the things. So on the left-hand side, you can see the system under test, endpoints, or anything which is a node. It could be an API, it could be a system, it could be an IoT or a Car2X interface. It doesn't really matter. We support them all. The next thing is around lifecycle virtualization. You don't have the endpoint. Well, that's fine. We've got, service virtualization or network function virtualization or network virtualization or database virtualization. It doesn't really matter. Whatever your lifecycle virtualization is, how you shim and stub those systems upstream and downstream to create sandbox environments, we provide the flexibility to test those as well as real systems. Now, what we do when we're talking about testing real systems, we're talking about hyper-baselining. Hyper-baselining is understanding the current state and be able to capture that steady state and create a digital twin out of it, which I'm going to show you later. But within our open testing kind of architecture, we of course have the digital twin at the heart. And then within the digital twin, we have two kind of approaches. We've got the shift left approach, which is being able to use model-driven design techniques or model-based testing techniques. And then we've also got this bottom right-hand side talking about multi-dimensional transactional data. So this could be things like open telemetry. We can feed that information in, and we also have a product called Real Customer Insight, which will pull that information, that beacon data, and then we use multivariance analysis to be able to create out of those multi-dimensional data sets a digital twin. And of course, we have the ability to adaptively store the hyperbaseline steady state and the real world steady state on the shift right perspective. So shifting left with hyperbaselining and shifting right with multi-dimensional transactional data. And then we're actually able to create both two really important components. The first is the asset-driven generation. And this is this ability to use AI to generate the actual automation that you need to run. And then we have the AI fusion engine on the left-hand side, which means we can automate anything. It doesn't matter what the endpoint is, we can test it. And then within our metamorphic model-driven engine, what that gives you the ability to do is deal with all types of states, all languages, all variations, all states, all data. Anything you think about how a journey could alter by, errors, challenges, negative or positive testing, we can do. So within my TED Talk, I talked about cognitive learning, the ability to think, make, and learn. So how do you feed back the learning, i.e. the operational state, into the thinking and the design? How do we make this into a evolutional model? And I'm taking kind of what Tom Gilb used to talk about when he created Evo back in the 90s, around taking the think, create, and learn segments and then feeding them back into the model. And we do this in a very similar way that you've seen with the other kind of infinity signs, is we're taking the learnings to then input the design, the modeling, the build, the testing, and then we repeat. So there's a feedback loop. And we refer to this as cognitive adaptive testing. So the ability to adapt to what's happening in the real world, to create new test cases, new journeys, new devices, new ways of interacting with the system, new behaviors based on cultural or regional events. So what we're really talking about is a digital quality lifecycle, the ability to deal with any type of digital experience, and whether we're doing performance, functional, visual testing, accessibility, it doesn't matter. We can use our AI bug hunting algorithms and our universal fusion engine to test anything. We've also got robots and anything else you could possibly think of, whether it be NASA to fighter jets. So within our DNA, we're all about securing, automating, and providing intelligence at different levels, measuring, analytics, and workflow automation. So the book that I showed you, what I've just launched, was my fourth book. The title is Shifting Right into the Metaverse. And you can see behind me the augmented reality, which actually one of our customers talked to us the other day about how we could look at testing two separate stereo feeds coming from cameras on a headset, and then be able to understand where data's been augmented or using LiDAR or any kind of other technologies. And that shift right approach is taking the information from what's happening in the real world, and of course things like the metaverse are blurring the boundaries between the real world and technology. We're shifting that information across, so we capture it, we reverse engineer it, those real world journeys, and then we create a model. And then we've got this true to E2E, we can do it risk-based, we've got this cognitive quality engineering capability to understand what should we be testing, things like feature clustering, which I'm going to go through in a second. But first, I wanted to kind of give it as a very simple viewpoint of, well, how's this done? Now, one of the things that we've had to explore with customers is it's not always revenue generating. It could potentially be based on a positive outcome. So if you're wanting to establish a connectivity with a particular device, just because it fails doesn't mean that the system's failing. You have to look at what are the behaviors that we're trying to observe and also be able to test, and then wrap around exhaustive testing in that landscape. So I'm going to give you a quick example. And I'm not going to take NASA or SpaceX as this particular example, or some kind of complex battlefield system. I'm just going to take our website as a really easy example. And it's very quick, literally within 30, 40 seconds, we can create a digital twin of our system under test. So every interaction of thousands of people that are coming into our site right now. And then we're able to create the correlation of those events of what they went to, what the journeys were, and they're able to model those journeys into a flow of how they've gone through the site, and then do every single permutation of every single combination, and be able to capture that from today, from tomorrow, as your digital twin evolves. So this digital twinning capability of the hyper baselining state could be in production, it could be in test, it could be in development, it could be in staging, performance, UAT, BAT, it really doesn't matter. But it gives you this ability to quickly test and generate a digital twin. So let me show you with something, but I log into a Salesforce system, I want to generate my unique DNA of how I set up my ERP or CRM system. So within that, I can straight away pull down all of those permutations, whether it be a count, it might be a different section, generate all the test cases that I need, both negative and positive, bring down the information that's custom to us, generate that digital twin, and then from that digital twin, literally run it within 90 seconds, and then be able to test your system, whether it's running on a browser, on a mobile, it's using two-factor authentication, it's on any device in a secure environment. If there's a UI, an API, a database, or messaging layer, we can test it. So I talked a little bit about actually how we transpose and understand multidimensional data, which is the type of information that we measure whilst we're actually looking at a system under the test. So we actually have this on our Salesforce instance, monitoring every single transaction we do in production. So we use the word we're eating our own aubergine, but we're actually monitoring and measuring and understanding behaviors, even from our internal teams. And within that, we're able to provide this kind of feature clustering of understanding user journeys, understanding behaviors that we want to kind of encourage and ones that we don't want to encourage. So part of it is we can understand those complex scenarios that your customers are doing, and then make sure that A, you're testing them, but B, they're coming out with the right outcomes. And of course, this is incredibly complex. Not only your UX, your application layer, your protocol layer, physical layer, all of the capabilities that we can test. So, for instance, scalable networks was acquired as part of a Keysight company last year, which enables things like network function virtualization of the battlefield and create a digital twin just from network interfaces. So for every layer, we've got a solution and we've got a capability, as well as anything you can see, we can test. So I'm going to give you a quick demo of this running in the wild and the strength of not only having software capability automation, but also hardware automation. So on the right-hand side, you can see an incredibly simple model, and you can see the system testing it. Now it's connecting to the internet, and straight away, as soon as it's trying to do some downloading through speed test, you can see the signal analyzer at the bottom is picking up the signal. You can see the battery drain from the waveform analyzer at the top right-hand side. You can also see the battery being pulled down, how much is being used based on the activity that the phone and associate hardware is doing. We can emulate the network function virtually, the things like GPX, and we can also inject things like network function virtualization to deal with packet loss and jitter, to emulate different types of networks, all possible through Eggplant and Keysight's automation solutions. So we've got these next generation cognitive quality engineering capabilities, which you can consume today, modeling incredibly complex systems and states, and allowing you intelligent user journey optimization and intelligent asset creation, among a few things, as well as things like robotic process automation and much, much more at an enterprise scale across the entire landscape of your organization. So I'm going to take it back a little bit to the first book that I did on experiences of test automation. And at that point in time, I was working for New Zealand Lotteries. And of course, you can see the infinite amount of probabilities of buying tickets and combinations. So the route through this simple system of buying tickets, checking tickets, is not in the hundreds, thousands, or millions. And so we can take those states and we can apply proven statistical models to allow us to test all those possible permutations. So what does that look like in the real world? Well, I'm going to take a bit of an example of when I was working with the MIT COVID team for creating a vaccine passport and also a contact tracing app using not only GPS, but gains. You know, part of it is you can create a model and that model will change. It will change depending on the type of batch you had, whether it was Pfizer or Oxford. And it will be doing all of these calculations in black box systems, which could be fed in from ML kind of machine learning kind of algorithms. So the complexity around testing these systems is immense. But not only that, we've got to test them on every single combination in every single language. So in the example you can see here, so you can do your multilingual testing. You can start off with one language, change to another, validate all of those things, make sure that they don't run off. They're visible, they're interactable. Part of our using our computer vision capability, powered by additional OCR capabilities, we can test all variations of all types of screens, all types of devices. We've also got support for things like virtual USB that allows us to test on remote devices, as well as physical locations, physical devices located within your labs. So we've got this capability of quickly being able to create a digital twin. As you can see here, there's a great example where it's already come off the edge of the screen, and you might not be able to click on it. And of course, if that's going to block somebody from being able to report, a COVID positive things, it's going to cause problems. And again, this supports your entire quality stream management and your quality engineering teams. It also supports your operational teams for things like site reliability engineering, chaos engineering, being able to do real user testing, and then learn from all of that, inform the models and feedback. It's no longer just QA in a silo. And with that, I just wanted to kind of summarize just our breadth of ability and capability within the Keysight family and all of the tools that we have, from network security, data analytics, to design software and testing software with our both classic and also Eggplant capabilities. So wherever you are in the life cycle, we can offer you next generation predictive analytics, connected intelligence to make your testing awesome.